Pleased to have Rachel Burton here from Piedmont Biofuels, who is going to be talking about ASTM standards, which we'll hear from Bob whether it's relevant or not to home brewers, in which Rachel just asked me, does anyone really care about ASTM? Hopefully we, raise your hand if you do. I guess we got a few that do. How about that? So we're going to turn the time over to her without further ado because we had to move, and welcome.
All right. Before we get started, I would, since everybody raised their hand, can anybody shout out besides glycerin, because I know we're going to really go into depth on the GC on phthalate-free glycerin with Bob. What other things that you're concerned about in relation to the ASTM specification?
Catalyst, residual catalyst, residual methanol, residual water.
Okay.
How close do we actually have to be before it matters, and what engine time?
Last point.
Last point. Just like the changes in recent.
What it measures and why it does it.
Okay.
How often is
Don't
that?
need to run over there,
What?
don't need to run over
In the
there.
back there?
That machine.
Tonight, yeah.
Okay, we're gonna get, yeah, I need beer for about 5 minutes sometime.
Those are
Okay.
definitely
I got a deal
the
going
ones
on.
that you guys mentioned. The issues around residual catalyst and residual alcohol are definitely some key issues. And I'm going to speak from just personal experience, both on our co-op level, which our co-op is now proudly meeting ASTM specification fuel, and we're about to transition into commercial sales of our co-op fuel on road. And then the other, where my real experience in the last year is setting up a lab for our industrial production facility, setting up the certain methods that we're going to test in a process format, and then the actual, we produce 20,000 gallons a week, and we make 4,000 gallon batches every day, and we have to test certain ones before, and how we kind of move through the process, which methods we test for on a daily basis, which ones we test on a weekly basis. So that's where I'm going to speak from. So we're going to look at all the different key elements in the entire most up-to-date ASTM specification, which in the last year and a half, there has been a significant amount of changes to 6751, which is the 100 biodiesel blend stock ASTM specification. Is the one that has like the 16 different methods, and they keep adding one or two here and there. So we're going to look at all the different properties, and I'm going to kind of go through the ones and specifically look at the ones that you guys are interested in, and I can tell you my experiences, and you guys throw out some questions as we go along. 6751 has actually 2 grades now since we changed to ultra-low sulfur ULSD, and that's S500 and S15, and that basically means that the sulfur level in your biodiesel has to be at least 15 parts per million if it's going to be S15, or it has to be 500 parts per million if it's going to be S500. Typically, like it says, most biodiesels are going to meet that S15 level no matter what. Steve?
I understand that we're going to 5 parts per million in the next few years. Do you know what that is?
I don't know what that is. I think that engine manufacturers, OEMs, and even the EPA and the whole fuel industry is having a hard enough time with B15 right now. And I think that even though people might say we're going to 5 pretty soon, there's going to be a lot of resistance to getting to 5. Go ahead. Question?
So that's the sulfur in biodiesel?
The sulfur content. So your biodiesel has to have a sulfur content that meets ultra-low sulfur diesel. So basically your biodiesel has to have at least, if it's going to be on-road, 15 parts per million or less of sulfur. If it's going to be off-road, it can have 500 parts per million. Some biodiesels do have sulfur. And I can speak to that right now, your yellow greases and your animal fats will, in the feedstock, if you have it, you can have it analyzed for sulfur content. So I've had a number of yellow grease samples and chicken fat, we process poultry fat, and Piedmont. that are anywhere in the 40 to 50 parts per million on the feedstock range, and then the actual process, the transesterification process, brings it down below that 15 parts per million. So it's just something, we check it, we don't check it too much on the feedstock level because we get a consistent supply. But sometimes excess sulfur in your feedstock can cause processing problems. And sulfur analyzers are really expensive. All right, so here's the current, most up-to-date, and I just threw in some, the things that at the bottom, oxidation stability is a recent new one. Workmanship, that one is more of a parameter that is, people want for BQ 9000, which I can speak to in a little bit. And then all the ones in purple are really the key parameters in terms of if you pass those, you'll probably pass everything else. Go ahead. Flash point, water and sediment, sulfated ash, which is a measure of residual catalyst, acid number, total liquid glycerin. And then sometimes people put in phosphorus content.
Acid number is measuring oxidative stability among that and rancid.
Right. Which is the oxidative stability.
Are these all separate tests that comprise 6751?
Yes. So each one of these numbers, the test method where it says D93 or D2709, that is like an actual method, and it has all these instructions, and I'm going to go through point by point of what it tells you, how to basically what equipment you're going to need, how you're going to calibrate that equipment, what kind of reagents you might need, what kind of concentration those reagents are supposed to be in, and the process in which to properly go by that method. And you were supposed to purchase these methods from ASTM directly, which is American Society for Testing and Materials. There's different committees that determine these methods and go through long, arduous meetings to decide which method is going to be used.
When you say method, you mean the actual field-making method?
No,
Or the
test method. So when I say method, like D93 is the test method for measuring the flash point of biodiesel or petroleum.
When you say buy those from
Purchase them. So typically you sign up to be a member of ASTM, and then you purchase specific. Or if you don't want to be a member of ASTM, or you are somewhere close to a university, you can have access and look at the ASTM methods through the library. They may not be the most up-to-date. And so if in a commercial industrial process, and you're stating on your certificate of analysis that my biodiesel meets the most current level of ASTM 6751, you want to also be knowing exactly what the most up-to-date ASTM methods are. So you've got to be able to purchase them and know if you're going to perform that method, if there's any modifications, they change and edit the methods every time the ASTM committees meet, and they meet pretty regularly, like quarterly. Question in the back?
Scared us to death. What's the cost to purchase them?
$30 a piece, sort of.
per method?
Yeah.
Oh,
You can get the full 6751, like a CD, and then the method specifically for like $300 or $400.
But the cost of the test equipment to run the method
well, yeah, that's.
is really the big expense.
I figured the method was going to be as expensive as the equipment. Never mind.
When you purchase them, is it like a subscription for a year, or is it just a one-shot? You get the version that's available?
You get the most up-to-date version right there. So you can download it on PDF, or you can get it in paper form.
Do you think it makes the most sense to actually purchase those methods, or just to send it off to a lab that can certify it?
It depends on which methods you want to do. So if you say, I want to do flashpoint, water and sediment, and total and free glycerin, then you should purchase those methods in which that you're going to perform those, because you're going to need to know how to calibrate your equipment properly. So if you're not going to perform acid number, don't buy it. You don't have to buy it.
Well, I'm saying, so like on the right side, there's the, you can just buy the kits and you send it into the lab and they can do the testing for you. Right?
You don't need to buy the ASTM method. If you're going to outsource your fuel testing, don't waste your time.
But what, I guess what he's saying, look more
One other
economic.
question before I move on, because I got a trillion slides.
There's another number always here, it's like we're at 98% or higher than we could.
Right.
What's that refer to?
That is referring to the conversion rate of your biodiesel. So if you have converted all of your triglycerides into methyl esters. So typically, if you have a 98% conversion rate or better, then your fuel will be the full 60. There is a European test called 4% esters by GC. It's not required, it's not a method required by ASTM 67. But there is you see this number here, EN, those are the European methods, and D are the US ASTM methods.
If I could just comment real quick on that. When you're measuring glycerin, you're looking at the other side of that equation. So when you're measuring glycerin, that's unreactive, okay? What Rachel's talking about is then how much has been converted.
Right.
So it's like saying, so you're looking at the same thing in reverse when you're looking at down and restarting glycerin, up, down glycerin.
All right, I think we all know what the definition of biodiesel is. All right, here's my your friendly local sales rep at Petroleum Analytical Equipment Company, who will gladly sell you lots of really expensive test equipment, and he might buy you some margaritas as well. But it doesn't get your price right on the equipment. Last year I had the privilege to go out to Magellan Testing Laboratories, or Williams Testing Laboratories in Kansas City, and they had a whole week on how to test all the different methods, how to use all the different equipment, and it was very, very helpful in terms of me setting up my lab, especially not being a trained chemist, specifically to be I'm not an analytical chemist. A picture of some of our test equipment. Some of you guys saw that in the safety picture. So the testing procedures, we've already kind of hit this in terms of the standard has all these different methods. So we've got 15, 16 different methods, and they are very explicit in that they say you should use this type of thermometer, or you should use this type of motor, or this type of water bath in which you are going to use this method. And the reason why they do that is Bob is part of a cross-check program of a number of labs, and he let me throw in my samples recently into the cross-check program, in which people across the country, they all test the same fuel, and they send in their results, and they've all calibrated their machines and their test procedure by these ASTM methods, so they can kind of see, well, when I did the glycerin test, or when I tested for acid number, here was the level on that fuel. So you can kind of see where you are in terms of the performance of your machine, or if you're way out of whack compared to everybody else. Because everybody is trying to do the same exact method with very similar equipment. So when you go into a 5-page document, ASTM method, it's broken down by these 12 different little, so they kind of give you the scope. It's like, okay, why are we doing this? Kind of abstract introduction. They'll give you reference documents. So a lot of times ASTM methods will reference other procedures, other tests for water and sediment, or other tests for similar tests, and say, hey, this is kind of like this. Maybe you're familiar with this test method. They'll give you the terminology so you can learn, like, okay, what is a gas chromatograph, or what is a flame ionization detector, that kind of thing. So it's basically an outline, and I give you these are all the different things that are going to be in the method to help you explain. this stuff can be really mind-numbing. Like, you need to read it 5, 7, 10 times before you're like, interferences, apparatus. I don't know. Sometimes it can be kind of confusing. But it also is pretty straightforward in terms of, it tells you how you're going to actually perform this. So like the 6584, the total glycerin method, it gives you the recipe for how you're going to prepare your sample. And it's pretty basic once you get it. Sometimes they have really nice math calculations that require you to call your uncle who is a PhD math scientist, and then you analyze the method. Anyway. So this is just how the report is actually structured. So let's go into Flashpoint. Flashpoint is actually a test that I don't test all that time. Like every batch, we don't test it. Because we've seen in our process that we wash our fuel so much, by the second wash, all that methanol is gone. So I know generally that my fuel is meeting the Flashpoint. Where I do actually do a lot of Flashpoint tests are on other people's biodiesel that I bring in, or glycerin samples to make sure that they are non-hazardous, or in some of our experiments. And I was talking to somebody yesterday in the break room about how you could actually make your own kind of homemade Flashpoint tester. Because essentially what it is like an electric heater. You could take a hot plate stirrer, and you're going to try and ramp that temperature up to a certain point. And you're mixing your sample of fuel, which is about 100 milliliters of fuel, and it's in a closed cup atmosphere, so you've got something that's got a lid on it. Let me move to a picture so that you guys can kind of see. This right here is the belt where it's holding in. There's a big electric resistance heater under there, and it's holding in that heat, trying to get constant heat all the way around the cup. And then there's a little flame, a little igniter, in which every so often, like as the temperature ramps up, the cup will open up, and it will dip that flame into the area where there's a fuel-air mixture. And if the vapor above that fuel is hot enough to ignite, it's going to ignite, and you're going to get a flame. And it's a pretty simple test in terms of once the flame goes down and it goes poof, you know that's your Flashpoint. These are all automatic Flashpoint testers, which are pretty expensive. I think when I was pricing them, they were like $7,000 or more. We have a manual Flashpoint tester, and it takes a lot more time because you have to sit there. You have to be the person that actually opens up the little cup and the flame dips down. But if you don't do a lot of Flashpoint tests, it doesn't matter. The time to do it. On biodiesel, it takes a lot of time because our Flashpoint is generally really hot. So you have to start somewhere below where you think methanol is going to come out, which is around 140 F, 60 C. So you have to start around 45 C and then get all the way up, and the point in which you'll actually see the biodiesel flash maybe at 300 degrees Fahrenheit. And it takes time to get up to that 300 degrees Fahrenheit because you're checking the Flashpoint about every 9 degrees. That's what the method states. Interesting changes in Flashpoint have happened recently in the last version of the ASTM specification, in which they've lowered the limit for Flashpoint. It used to be 130 C, and now they've changed that down to 93 C. And then they added this other thing called alcohol control, which Europeans, this is kind of, the ASTM method is slowly starting to mirror the European method. So they've added this, hey, if you don't want to do the flashpoint closed cup method D93, you can do methanol content and test by GC the percentage of alcohol, the percentage of methanol that is still in your biodiesel. And that actually takes different equipment on your GC than what Bob will talk about. So sometimes you might have to have a second GC just to test this method, which is kind of a pain if you only have one GC, or if you have no GC. So the methanol content in the European method is 0.2% max. I think that if I remember correctly, some of the change, why they recently changed this is because of contaminated B20 samples and not being able to, and also B100 loads, people loading up product after loading gasoline tanks, and they were trying to isolate whether there's residual alcohol still left in the tanker. Do you have any comment on that, Bob?
No, I think that's right. The residual gasoline left in the tanker.
Exactly.
And
So.
a very small amount of a volatile material, so something like 0.5% of volume of methanol will drop your flash point way down. So the tanker can go woof, right? If some guy's smoking a cigarette on top, it won't burn, but it'll go woof, and that's not a good thing.
Right.
That makes sense. Kind of like your little flash tester, only bigger.
And even if you get on top of a tanker truck, a 7,500 gallon tanker, if they've had diesel product in it and you open the lid, it has some pretty good head pressure just off the diesel, and it will pop up on you as well. The other point that I was going to make, I just remembered it. Oh, 93C is keeps the biodiesel out of a hazardous material range. So like my B100 tanker truck that's 1,600 gallons, the flash point on it is out of a hazardous material range, so I don't have to, my truck does not have to be placard. So that's why they didn't go anything lower than 93C.
It should be 140 Fahrenheit.
Is that state or federal?
I think that's a national federal
Federal.
law.
Department of Transportation.
All right, so you guys see the flashpoint testers. These are the ones at the North Carolina Department of Motor Fuels Laboratory. They have like a bunch of automatic flashpoint testers because they're constantly checking for gasoline and diesel contamination. Because they don't want gasoline in their diesel fuel. I don't know why I put soap test in here. Can I come back to that? Y'all remind me to come back. Soap test is way more. Next one that we test for on a regular basis is water and sediment. And the method for that is 2709. And this is measuring the limit of free water and sediments inside your biodiesel. So any of the contaminants, any soaps, even any rust particles that might be coming out of your tank or something like that. So you take a little centrifuge tube, and they're really expensive. Don't break them. We've broken a number of them. And they're really hard, if you get the cap stuck in there, they're really hard to get out as well. So you take 100 mils and you put it in the centrifuge at, it says 800 RCF. It's about 15 minutes. You let it run for 15 minutes, and then you pull it out. And it's graduated, like it's got a little graduation on the side of the centrifuge. And your measurement, you're trying to look for 0.05 of a mil. So that's 500 parts per million. So it's like really, really, really small. So my centrifuge tube is graduated. It has 5 different graduations of 0.01, 0.02, 0.03, 0.04, 0.05. So that I can really be accurate on exactly how much water and sediment. Typically, this is one that we don't have a hard time passing, the water and sediment. Because if anything, occasionally we'll see some soaps fall out as our sediment.
Rachel?
Yes.
What's D6217 and D2276? Looks like those are other water and sediment testing from ASTM 70. The difference between
Those two? No, not really. I mean, I don't know. I have the 2709. Those are probably other reference methods in how you can determine water and sediment.
Right.
Is 2276 the Karl Fischer one? There's all kinds of different methods out there that are written for determining, test methods for determining different things. People will change them and say, I think if you do it this way, using this piece of equipment is a little bit better versus this piece of equipment. And so then they change the numbers. This D2709, a lot of the test methods in the ASTM specification are taken from the petroleum diesel specification. So they were just like cut and paste. Yeah, we should do, if it's tested on diesel, we should test it on biodiesel. So a lot of them mirror, and some of them don't really have a good relation to biodiesel. Like testing distillation on biodiesel isn't as important as testing it on petroleum. Steve?
Do the tests ever get jerked around or reused? Keep small producers out, say. Almost pass the pass.
I can comment on that.
You, go ahead.
No. No. And I'm serious about this. You know, think about the folks who are sitting here. These are chemists, these are chemical engineers. They really, Steve, don't have that agenda at all. What I have seen is when those proposed methods come up for what's called balloting, okay, to vote in, do we change the spec up or down? Some of those people, Delphi, Bosch, fuel injection pump manufacturers, also have seats. But aiming at small producers, no. Aiming at keeping higher viscosity fuels out of fuel injection pumps, yes. Is that evil? It feels like it, but no, right? But, so these guys, I guess the people who sit on ASTM committees, they are techno geeks. They're much more interested in determining what makes the most sense for the equipment than any particular political agenda. But I might be naive about that.
And I think it was more about engine warranties and the tolerances on the pieces of equipment and the time that their engineering staff might have had invested in developing certain injection pumps or injectors and how that fuel, whatever fuel that they've tested in that engineering scope as compared to what the new method will be.
They don't like biodiesel in general. So Bosch, Delphi, OEMs don't like biodiesel in general, and they shouldn't. Okay? I mean, and I'll comment on that on my time. But they shouldn't.
In fact, the technical folks at the National Biodiesel Board really do suggest that anybody that is a biodiesel consumer, user, advocate, get involved with the ASTM procedure. So if you want to go and sit in the meetings, like, jump on in. They will happily take your comments. It's like the more voices in support of biodiesel in those meetings, the happier the biodiesel industry is. All right, what about dissolved water? This is a question that Bob and I have had shots of tequila over. It's something. Sometimes, so you can have free water that's still kind of like suspended. You might be able to see it in your biodiesel. And in fact, one thing that I did when I first started testing water and sediment in our fuel, I was a little freaked out because I didn't see any. And I know this might sound kind of snobby, but I didn't see any water. I was like, I'm doing it wrong. There's got to be some water left in our fuel. And I learned this trick from the guy at the Motor Fuels Lab. If you take a 1 milliliter, like little pasture pipette, and take one drop and put it into your centrifuge tube, just one drop, and you will see at least 0.01 or 0.02 percentage of water in there. And you'll know that that's free water, so that you have no free water in there. And you can actually do this without a centrifuge. So, say you have a sample of biodiesel, like in a jar that's just sitting, it's your final fuel sample, you just take one drop in there. and it will settle to the bottom. So you know it's kind of like a measurement of like other free water that might be in there. It should settle to the bottom as well.
You're saying just by having it not be on one volume, just having little drops of milk in the water separate out as year?
No, it's just like I put it in the centrifuge tube, I ran it, and I saw nothing come out. And I was unconvinced. And the guy was like, well, if you ever want to know what one single drop of free water looks like in your fuel, whether it's diesel or biodiesel, just take it up.
Oh, and a drop of water.
Add one little drop of water, and you can see what that is compared to no water. So it gave me a really good visual indicator of like, okay, this is what free water looks like. Now we have had discussions about water that might be still in suspension that you can't centrifuge out. And how do you calculate that in terms of this method? Because this is supposed to be more for free water. And that's where we bring in a non-ASTM method, which is the Karl Fischer water titration, which kind of has, a lot of times we'll measure our fuel for water and sediment, and it comes out pretty nice, clear, no water, no sediments. But then I'll test it on my Karl Fischer machine, and it might still be 1,200 ppm. And that's really a measurement of, what I think is a measurement of water that's still in suspension in the biodiesel.
So I'll comment on that real quick. Agreeing with what you said, and so something I've learned since those tequila shots is we are on the right path here. And Karl Fischer is being balloted as the ASTM method now. So it will come in. So there's dissolved water, which is what, Rachel, when you're using the word still in suspension, it's dissolved, the solubility of water into fuel. The biodiesel at ambient temperatures will hold something like 1,500 parts per million. Okay? And so if you have fuel that's clear and bright, Rachel, and you look at it, you spin it with the centrifuge tube here, and you see nothing, you have no free water. When you go through that on your Karl Fischer device and titrated it, you found 1,200 parts per million. That was dissolved water.
Exactly, that's what I meant by found water. And the free water is what they're most, I mean, water in general, the fuel injection manufacturers are definitely concerned about, because that's what can cause corrosion on the internal components of the fuel system.
Do you recommend you get a test again?
They do.
We've also figured things are like
You can reach out if you want to try to open those things up and kind of put them in the sun, but we do use those test filters.
What are they? I'm sorry.
You just put it on the top of the tank, right? You're not filtering through it.
Biodiesel blends hold more water.
No. Diesel holds less water than biodiesel. So when you say blends, you're talking about with petroleum.
Yeah, so it's B20 is more or less likely to absorb.
It's less likely to absorb with the higher petroleum content.
B100 has the most likeness to absorb the water. It'll go along with it easier.
Got a question about water. Again, if it's dissolved within it, 1,500 parts per million, is there any known issues of having that water in the biodiesel? Does it cause any problems to the diesel engine at all?
I think that both free water and dissolved water over time can cause the corrosion on the fuel injection equipment. Because I think sometimes over time that dissolved water will settle out in your tanks, and it can cause the ability to increase your microbial growth in the tank.
That's right, and a couple other points on that. So when you've got that dissolved water, let's say Rachel's example, 1,200 parts per million, when it gets cooler and you've got that 1,200 parts per million, some of that's going to fall out. So just what Rachel's saying, where you're now going to have greater chance for microbial action at the fuel-water interface. The other thing is free water is really bad for injectors. It hits the end of the injector and goes and blasts them. And so this is what the fuel injection pump people are most concerned about with water, is free water hitting when it comes out of the injector tip.
Also a cold flow. You know, you have fuel that might have some dissolved water in it, and fuel that doesn't. What do you think is going to jump quicker? Stuff that's got some water in it.
Is the homebrew refrigerator tested the homebrew solution to this type of dissolved water problem? I mean, far as indicating whether your fuel is really dry or not? I mean, I know that's not exactly the same test, but, I mean, you know how you put it in the fridge, it piles up, you know, you got water and fuel. Is that what that's indicating? Is it indicating dissolved water?
I can't say that it's absolutely indicating your dissolved water. You know, you can take a sample that you think is one that's more dry than another, and the one that's less dry is probably going to gel up quicker, but I don't think you can quantify that exactly. We currently don't test for cloud point. It's kind of on my Christmas wish list, and I do use a refrigerator. But, you know, our water determination is just by the fancy Karl Fischer.
And you're not doing the refrigerator test to test for water.
No.
I would not get very worked up about dissolved water. Okay? I would get worked up about free water. And so if your fuel is clear and bright at the ambient temperatures, don't lose it a moment's sleep. Okay? And that's based on having tested fuel that's clear and bright at ambient temperatures, and you're well under the 500 parts per million free water. So yeah, don't get worked up about dissolved water. You can't do anything about it, basically.
If it's cloudy, you can tell that, you know, just a slight haziness is going to mean that you have dissolved water in there, and it's not dry yet.
Mine doesn't. But I just wondered if that was the same, or, you know, an equivalent home brew test for someone that doesn't have the equipment.
So assuming that there's going to be water in your fuel, is there something you can do for maintenance periodically to help the situation within congestion?
There are certain additives. I'm not sure if I directly recommend them, but I know that dealerships do use them. One of the Ford dealerships that I used to work with, they have a diesel fuel treatment that if they have vehicles that come in they think they've gotten bad diesel fuel, they actually do this fuel treatment in which that is supposed to absorb the water, the diesel fuel additive that's supposed to absorb the water.
Check your fuel water separator on your diesel equipment, right? And if you're not seeing water there, which I'll bet you're not, seriously, it's not an issue. All diesel fuel has water in it. That's why diesel equipment has fuel water separators. They work on coalescence.
We tell people to clean out their tanks before they put biodiesel in them.
Yes.
You've got sediment, water and sediment sitting on the bottom of that old diesel fuel tank, and it's only going to cause problems once you mix the biodiesel in. All right, sediment issues. So these are more like the centrifuge tubes that I use. So they, you know, 0.001, 0.02, 0.03, 0.04, 0.5. So that's how small in terms of 100. This is a 100 milliliter tube, centrifuge tube. And this is a sample of fuel that we received from a commercial producer a couple of years ago in the winter. I don't know if any of you guys experienced some of this like cold settling out that has now become this kind of larger discussion about sterile glucosides, of what is this mysterious milky white stuff. So this is before we knew what sterile glucosides were. And if anybody really wants to go in depth, Biodiesel magazine, Random von Weddell book, there's some literature about that. And it's something that's naturally occurring in vegetable oils. You will not see sterile glucosides, this waxy material, that can be quantified if you want to get off the creepy side, in vegetable-based biodiesel. And if they see it as a cold filter plugging the weak issue. You'll see it in animal fats.
Is that ambient temperature, Rachel? Wow. What did it look like before you spun it? Was it clear and bright?
It was a little bit hazy.
And what's the nature? If you tip that, is that like a lava lamp or?
No, that's pretty hardened stuff.
I've never seen anything like that.
Yes, that was 2 years ago in the winter, and we were having to heat our tanks.
Well converted though? Did you test this for conversion?
I did not. We didn't have the ability. We were building the plant.
I see what you got there.
To get something clear, we can do what it was, just a minor minute. We had passed the 327 test for this fuel. It had been sitting in the cold for a while, and we came back after a week, and we had a sample in a jar that had that looked just like that at the bottom. And we
sometimes people think it's monoglycerides, but now that they're doing more research, this is something that is just kind of in the experience of the biodiesel industry. They're saying, oh, there's this thing that occasionally settles out, and it settles out of fuel that meets specification. And it's a naturally occurring thing. It's not something that's gone wrong. It just exists within vegetable oils.
All vegetable oils or?
All vegetable oils that I'm well aware of.
So should you not run fuel if you have some Saturday night?
Yeah, I wouldn't run that. I would do like a cold filtering like we were discussing. You know, you can separate that. You could run that, you can heat that up. You can heat it up to 240 C. It takes a lot of heat to melt, put that, because typically it's soluble, but once it's cold, it will settle out. So the folks that are doing the most research and really know this issue is our good friends at ADM. And they have actually determined a method in a GC in which you can quantify whether you have sterile glucoside in your fuel. And there's a lot of people are just saying you just need to do more excessive filtering to filter out these sterile glucosides. I don't want to get too far, but I did want to. All right, here's a sample of a centrifuge. I didn't have a good picture of ours. Here's my good friend Greg. Greg is at home making fuel right now. I made him put on the Tyvek lab coat and let me take pictures of him before I did a presentation in Quebec last month. But this is our Karl Fischer titrator, and the Karl Fischer titration is a measure of, it can measure the dissolved water, it can measure the free water. In a parts per million, it'll give you a reading, hey, you have 2,000 parts per million of water, of moisture in your fuel. You can do this with diesel fuel, you can do it with B20, B50, B100. You can do it with feedstocks. You can do it with methanol. So if you think your methanol is contaminated with water and you're not getting a good full reaction, you can test the methanol for the amount of water that's in there. So we typically, we have these glass type syringes. I use a Hamilton gas type syringe. You pull out a milliliter or two, you kind of wash the syringe a few times with your sample, and then you pull kind of a clean sample, and then you inject it into the Karl Fischer. And it's this little glass jar that you see with the red liquid over there. It has several little desiccants on there so that to make sure that there's no outside moisture getting into the titration vessel. And what that red liquid is a mixture of methanol, sulfur dioxide, and purity. It is some nasty stuff. It stinks. So, and you don't want to spill it. But what's going on inside there is a majority of it is methanol. And there's a reaction that can happen in which the iodine will basically, I think it's the iodine, the water can be consumed in that titrant. And once the water is consumed, you measure, there's an electrode in there that measures the level of iodine. And so based on that electrode's measurement of iodine, it calculates how much water has been chewed up in the titrant. Does that make sense? Sorry, I was trying. People always ask, so what is the magic that's going on inside the red liquid? All right, kinematic viscosity. This is one that we do not test at Piedmont. We do have the ability to measure viscosity at our community college lab. So I will get to play around with that equipment later on this fall. And basically you're measuring how fast or slow the liquid is flowing. And typically, it can be feedstock dependent. So any thicker liquids that your animal fats, your tallows are going to have a thicker viscosity. They're going to flow slower than your other destroy your fuel. So, if I can, you basically, you suck in a level of fluid, and then you basically let it go, and you have a little stopwatch, and you're going to time it from when the liquid flows from here to here. And you plug in that time into a whole little calculation, and that gives you your kinematic viscosity. One of the first biodiesel plants that I ever went to, this was one of 3 things that they measured on a regular basis. So some people do it a good bit. That is a measure of sulfated ash. You need a really big hot oven for this one. So you're basically cooking your biodiesel until there's nothing left. And then you're going to measure the ash that is left after you char the biodiesel. And it is really an indicator of excess catalyst or residual catalyst and soaps. It is one that you do want to have tested on your fuel at some point. It's not a parameter that we test every day over at Piedmont because we don't have a big sulfated ash muffled furnace. But we do have it at the college. So when I got to visit the Magellan laboratories, the fume hood that they had under it was like completely black and dark. It was like you had to like set a little fire. So it was like anybody that's a pyro would love to do sulfated ash. So here's kind of what it looks like. It's a very highly insulated, high temperature furnace. Sulfur, we kind of mentioned sulfur already, and we talked about the feedstock variations. The machine, the equipment to test sulfur is pretty expensive. It's about $60,000 for a new Antex sulfur analyzer. Right now, it's cost prohibitive for us at Piedmont. So I luckily have some good friends down at our motor fuels laboratory. And you guys, at your state, most states have to test the things that are coming out of the retail pumps or coming out of the fuel terminals. And if you can befriend the guy at your laboratory at the Department of Agriculture, he might test your fuel for you for free. So I have the luxury of being able to take a tray of samples down to Raleigh and they'll inject it into their sulfur analyzer.
And how often are you doing that test?
Because I'm lazy and don't like to drive across the lake all the time and waste fuel just to go test sulfur, I'll probably get 10 or 15 samples, terminal samples, like once a month.
Commercial producers are required to test every batch of fuel-based sulfur. So what she's saying is she's consolidating 15 samples together to take across the lake, but those samples each represent terminal samples. Meaning for every terminal, each represent 7,000 gallon loads. Not something homebrewers should really worry about, but if you want to, for about $60 an outside level test your fuel for sulfur, it's not. But commercially, you have to.
All right, so here's the 60 grand box. Not an easy. Copper strip corrosion. This is one that typically no biodiesel ever really fails. I think it's a parameter that has come from the diesel fuel specification, and it's more in a relation to highly acidic or oxidized fuels. So it's not relative to what it's actually going to do to copper. It's more on an oxidized acidity. So they have little strips that you can test your fuel with, and then you measure it along the range. And I think you're supposed to be within 3. So this is something that they do. You do it on an analytical laboratory, but it's in terms of commercial, industrial. I wouldn't put this high on the list of something that you need to go out and do. Cetane number. That's the measure of the ignition property of the biodiesel or the fuel, and everybody generally knows that the cetane number biodiesel is actually higher or better than petroleum diesel. Typically, you're around, like soy-based fuels are 47 to 52, and some of your more high saturated fat fuels can be above 52, 50, or 55, something like that. How you measure this is how the cetane number is currently measured through a process inside an engine specifically called a cetane engine. It is also a cost prohibitive cost, like hundreds of thousands of dollars to buy these insane engines. And I think in the near term that we're going to see this parameter maybe move to something that what they call is a cetane index. So there's not a lot of people in the country that have cetane engines. There's only a number of laboratories that have them. We do have one at the North Carolina Department of Ag, and there's like one guy that really knows how to run it, and it's always a little bit temperamental, and they only run it like one day a week when they have a whole bunch of samples because of this weekend. And actually, Frank and I were talking about cetane yesterday, and how it's measured, I couldn't believe that I actually remembered this when we were walking on the street. There's this standard, there's a standard for, you know, the term octane, right? You have a chemical liquid called isooctane, and that relates to the value of your octane fuel, octane level of gasoline. Well, cetane has that same type of chemical standard, and it's called hexadeca cetane. And so you actually kind of run that standard, and in comparison to that standard is how you determine the level. You know, if this chemical is at 47 and yours ignited at a different temperature or ignited at a different range, then it's going to give it a different number of 48 or 49. All right. So if you want to look at what a cetane engine looks like, it's kind of crazy. It has all of these little wheels in which you have to they help calibrate different components of it. And it's really, really loud when they operate them inside. And Magellan, they have several different, they have a whole engines area where they're measuring, they have like 3 octane engines, and they have also 1 cetane engine. And you have to wear earplugs. Cloud point. Typically, there's a couple of different ways that you can measure cloud point. A lot of times, the European specification measures for CFPP, cold filter plugging point. And I think that, my personal opinion is I think that the ASTM method is going to go towards more of a CFPP test in the near future. But we have a cloud N4 point tester at the community college, which is just a dry ice bath and with little tubes, just glass jars and thermometers, and you cool it down and pull it out every once in a while and see if it's starting to cloud up. You can do that very similar in a refrigerator. So, no, we haven't invested in one at Piedmont.
Question.
Yes.
Do you think that the ASTM will ever establish a low limit for cloud point?
You mean like how?
How low they think that fuel should go and not like?
I'm not sure.
No. What they are talking about establishing is using a, gosh, I forget the name of it, but it's basically a 10 percentile minimum temperature based on where you are. Okay, so there's something diesel fuel people, I don't know, you know the name of that?
It's how they add number 1 and number 2.
Yes, how they blend diesel for cold flow. So that's looking at being adopted. In other words, if you sell palm oil, methyl esters in Utah in the wintertime, you're going to get in trouble commercially. Okay, so, but it won't be a cloud point number. So, my opinion.
You talked about cloud point and gel point. You know the difference, like I'm looking at it. What exactly is gel?
The gel point is more of when it becomes kind of like a jelly. Okay, clouding is when it's becoming hazy.
Pretty subjective.
It can be fairly subjective. and then pouring, the pour point is in which it won't pour anymore. And I've got actually a good picture of that.
There are ASTM methods for each of those that actually then quantify them.
Right.
They force stuff through a filter, for example, for a cold filter plug point, there's a method, and it chills it down, and once it blocks it to a certain extent, you get a number. It is quantitative.
All right, here's a really goofy picture of me. It had Magellan last summer. But this is a CFPP machine in which it basically sucks up a big sample of biodiesel and then puts it back down into this vessel, chills it, and then creates a vacuum in which it's trying to pull the fuel back up through into this vessel. And the point at which it can't pull it over a range of time is what they call the cold filter plugging point. So this one, it was really good. So in terms of, we pulled it out and you can see what CFPP is. And, there was still a little bit of biodiesel that was still liquid on top, but it still had gone past that range in which that it was able to pull the fuel back up.
Could you give an example number associated with some kind of fuel for a cold filter?
I'm not as familiar with it. Do you know?
What do you mean by a number?
What temperature?
Cottonseed oil will have a cold filter plug point of something like 25 Fahrenheit, 28. Okay, it has a cloud point of something like, no, it's probably higher than that. I take that back. So as you chill something down, you hit cloud point first, then you hit cold filter plug point, which is when you've got enough waxy crystals to slam the filter. Then you hit pour point or gel point, which means you turn this stuff over and the shit don't come out. Okay, so and it depends on the feedstock in terms of how much range between those numbers. So for our purposes, when we sell fuel, the cold filter we report, and you must, to the ASTM standard cloud point. That's when, hey, you're on the warning track, okay? So the rest of it is sort of semantics. The real deal then is know your cloud point and stay above it. And for blending, you should be 10 degrees above that cloud point as well as the petroleum diesel should be. That's what the ML handling guidelines say. Above the cloud point.
Here's just a couple of our pictures of different equipment. And the bath that's similar to the cloud point tester that we have, you can see that it's just a dry ice bath. It looks like an ice cooler that you get at a hotel room. And you put a little sample, so you can kind of replicate this. If you didn't want to do the refrigerator method, you could do an ice bath in which you have a thermometer and a little glass jar inside of it. It's very similar to what it is. It's an actual recommended piece of equipment for ASTM and cloud and fuel.
Rachel?
Yes.
Yeah. I'm curious about when you do all your testing, it's all on B100, right?
Typically, yes.
Okay. Now, as a blender, I mean, if you were a blender and you had to test for, you normally would just test your B100 and not whatever amount you're blending together. Do you get my point? Like, for instance, if you were a blender and you wanted to, like in the wintertime, for instance, right? And you wanted to sell the fuel at B20, right? Now, would you do a separate testing on the biodiesel and then another testing on a blended fuel, or is it even necessary? Or you get my point?
If the diesel fuel that you're purchasing from the petroleum rack says that it meets 973? 975. Too many numbers in my head. If that meets the petroleum spec, you should be fine. And if the biodiesel layer meets all of its parameters, it should be fine. So the blended product should be kosher.
But Lawrence, I think to answer your question, there is not a spec for B20. It's
Not yet.
very close. It's maybe going to be pulled out yet this year. I didn't see it.
Well, but my point is, Bob. Okay, if you've done everything you can to make biodiesel fully clean and everything, and you've got your testing done and you meet all your specs, and you throw it in some ugly, nasty diesel which in my experience has not been as tested, as
Diesel
clean.
can have a higher cloud point than biodiesel.
Yeah,
It
exactly.
can. And so, but because it's so, caveat emptor, right? Buyer beware. But
Well,
it's
buyer
again-
beware, but what about producer beware? Because if my engine is,
Okay.
you know,
It's not to belabor this point, but as if that happened to you, but it wouldn't because you don't run B20, remember, it's for suckers. But if you did, Rachel's responsibility at Piedmont is to show that her fuel met the B100 as used in blending stock. And so when she can do that, because she's got the retained sample, okay,
Right.
then your beef is with petroleum people, and good luck.
Have fun with that one.
yeah. But the point is, again, you don't test for a blended thing.
I'm going to run through the next few really, really quick because they're low priorities. So carbon residue, it's a holdover from petroleum. Even in the petroleum industry and diesel engine manufacturers, they don't see it as a good parameter for giving whatever your carbon residue number doesn't really equate to what is going to really happen in terms of carbon deposits in the engine. So it's not a huge important thing. Acid number is something I check all day long. I do acid number we do it on the feedstock on the way in. We do it through the process, and then we do it on the fuel to make sure that it meets spec. It recently lowered its specification from 0.8 to 0.5. It's a measure of residual free fatty acid content and oxidation. This is how we test it. So you can do it on a bench scale. It's just like doing a titration. Just some of the reagents are a little bit stronger. So like the homebrew titration is significantly dilute and compared to the KOH water that you're going to use in acid number. And the volumes of your sample are also a little bit different. So sometimes you use 20 grams, 100 gram sample of biodiesel. You're not required to use the phenolphthalein, but that's what I kind of grew up on, so I still use it in my acid titrator, so I can kind of do it. So this thing will do it automatically, but I'll still stand beside it and make sure it's doing it right.
What's it will cost?
I think that one could be around $5,000 or $6,000. But I tell you, this piece of machinery I use a lot because I can do the soak test on it too. And the AOCS soak test method can be very subjective in terms of people's eyes and the color change. Yes, you can do this just like a homebrew titration. So acid number is just very similar to doing a homebrew titration. You're just doing it on the biodiesel itself. You're calculating how much residual free fatty acid or the free fatty acid content of the biodiesel sample. And if anybody wants to know the recipes, I'll tell you afterwards. Free untitled glycerin, I'm going to leave that to Bob. He is going to go all in depth on it. I just thought I'd throw up a couple of pictures of GCs. And Bob's ex-girlfriend, Deanna. That is Deanna.
She's the coolest person on the phone.
Yes, she's very, very helpful. She's a lab manager over at Magellan Laboratories. And so she's kind of
Not
just showing
surprised
us.
to see the gray hairs, by the way.
All right, phosphorus content. It can be an important one to test for, but it's not on the high priority list. Where you see phosphorus go out of specification, if you're using crude soybean oils, things that have not been fully degummed.
What about magnesium?
Magnesium.
Magnesium.
Magnesium use of residual magnesium measure.
I don't know. We're not magnesium users.
Yes.
Is there a new test in ASTM for magnesium?
Yeah, it's class 1 and 2 metals, which is I think. All right, distillation temperature. This one you will see leave the ASTM specification. I swear probably in at least a year. They're going to do it into a simulated method. So this one don't need to worry about. Woo! Class 1 and Class 2 metals, this is recent addition to the ASTM specification. Where this comes from is a request really, I think, from the fuel injection equipment manufacturers, the engine manufacturers, because of the issues of filter clogging, engine deposits, wear on your injection fuel pump. So all 4 of these, residual calcium, magnesium, sodium, potassium, they can be abrasive solids, so they can be actual little particles, or they can be soluble soaps.
And they can come from your wash water.
Yes. So these, and it's less than 5 parts per million on all of these. The next one is oxidative stability. That's also a measure of how long the storage length of your fuel. That's measured by 2 pieces of equipment now. One's called a ransomet, and one's oxidative stability index. OSI is a piece of equipment that is used in oil refining, like vegetable oil refining. And they're really expensive, upwards of $17,000. So I have a quote in my email inbox for $69 for oxidative stability. Fuel oxidation, since we're kind of running out of time, I'm going to kind of pursue that, because I think that these other biodiesel testings, and we can kind of talk about that. I know that Steve and Braden are going to kind of go over some other biodiesel testing. So here's one of our really hard methods that we do at Piedmont. I stick leaf behind the sight glass underneath the tank and make sure that I can see the little red parts of its eyes. We do sell the flip test over at the co-op a lot of times to some of the other home brewers in our community, and I'm not really going to talk about flip test because it's great. But we do use it on occasion, but we have all the other stuff, so we don't use it a lot. We do use it in class. Occasionally, we'll also do the 27-3 test, and I think, Bob, you're going to do the 27-3 test. This, I'm a big AOCS geek, so I like some of the AOCS methods.
American Oil Chemist Society?
American Oil Chemist Society, people that have been dealing with vegetable oil processing and animal fat processing, lipid processing for years and years and years. And they have some really good indicators, test methods that I think we'll see actually get incorporated into ASTM methods and even European methods in the near future. So this is one that we do all the time in process, in our wash process. It is not required, but we do put it on our certificate of analysis. So I typically don't let fuel leave the lab until it's less than 20 parts per million of soaps. And microbial growth, we kind of already discussed that. We have seen some microbial growth that has happened over time in some of our distribution tanks, and we have used the little Algex samples, and so if anybody, we see those as good indicators. We've treated stuff and then we filtered it out. We had one tank that we had to drain in the last year that we saw. Basically, it was causing excessive filter clogging. Pumped the whole tank out, cleaned it, treated it, and went on. These are specific gravity and pH we can do by our acid titrator, and we don't typically do specific gravity. I've done it on glycerin on occasion. BQ9000, those are marketers or producers that want to pay the National Biodiesel Accreditation Association to certify their process to make sure it's not like your product is BQ9000 certified. They're just basically a record keeping certificate, and it's like ISO 9000 certification. It's a very intensive record keeping process. It can be kind of expensive. But what you have, if you want to be that type of producer, where you want to purchase biodiesel from a BQ9000 producer, what they're required to do all the time is flash point water entitlement. All these sulfur and oxidative stability. So these are the ones that they are required to do if they're going to be part of the BQ9000 program. And that is first fuel. that came off the line this fall. That's myself and Lee and Lyle. Late night after the first batch ran on our commercial process. So you can see we've all got some shit-eating grins there. If you ever have any questions about fuel testing or anything, I know that Bob's tested a number of samples. I'm generally, if I'm not super busy, I'm pretty open to helping people out, figure out stuff on their process and taking samples in. So feel free to give me a call, send me an email.